So this is the game we are going to build in Action. As soon as you open the game, you come across with a treasure map, and all you have to do is to click anywhere on the map to begin your hunt. Each click represents an attempt to find the treasure. With each click, a hint appears telling you how close you are to the treasure. For example, let's click here. Cold. It means we are relatively far. Really cold. So far. Cold. Really cold. Cold. Warm. I'm near. I'm close. Found the treasure in 10 clicks. So you see a success message pops up congratulating you on finding the treasure in a certain number of clicks. And as you see, the game keeps track of the total games played and the total games won. Every time you find the treasure, it logs the number of clicks it took you to win that round. This information is displayed here below the map. Let's play again. Really cold. Freezing. The distance is still far. Warm. Hot. Boiling hot. It means I'm very close. Boiling hot, boiling hot. I found the treasure in 32 clicks. We are saving this data in local storage, so this means that the game stats persists even after you refresh the page. All the data regarding the games you played will remain available until you press this reset button, and this ensures that players can continue their game progress without losing their stat, making the game experience consistent. And in case I want to refresh the game history, I just press here. Game history has been reset. In order to create this project in React, you have to run this command, or you have to open up your terminal and you have to run this command. By running this initial command, you are creating a new project with React. In this case, with Vite. Vite will handle the build process while React provides the framework for building your user interface. And you need to have Node.js installed on your computer in order to use this command for creating this Vite React project. So remember, Node.js. And something I want to add is that we will only focus on the functionality and logic, not on the design, which will be provided in the CSS file linked in the description. And now let's start with the first part of the React configuration. So first we import the core library for building user interfaces, React use state. This is a React hook that lets you add state to functional components. And useEffect, that is another hook that lets you perform side effects in your functional components, which are, for example, fetching data or directly interacting with the DOM. Then we import this CSS file, and then we import the image. We assign it to the variable treasure map. And this is the image where the game will be displayed. Alright. Then we define our functional component named app with the return statement that defines what the component will render. Currently it returns just an empty fragment, but then we will fill it with the part of the application. Next we will define the state variables using the useState hook to manage the game's dynamic data. The useState hook is used to add state variables to functional components. Each call to useState returns a state value and a function to update it. The state variables hold the data that will change over time and that the component needs to keep track of. For example, in the target state, this state will hold the coordinates of the treasure on the map. The initial value is an object that will hold an x and y properties that will define those coordinates. And the updater function, setTarget, is a function that will be used to update the state target. Next, the distant hint state will hold a string that provides feedback to the user about how close they are to the treasure. The initial value is an empty string. Then clicks state will keep track of the number of times the user has clicked on the map, and the initial value is 0. Then we have games played, which will track the total number of games played. Then games won, which is a state that will hold an array of the number of clicks it took to win each game. The initial value is an empty array. And now let's focus on the return statement. Here we will define the structure of the user interface, which includes displaying the treasure map, showing hints about the treasure's location, and tracking the number of games played and won. So this structure includes an heading that displays the title of the game, then an image element displaying the treasure map that we save here right at the beginning. The source property sets the source of the image to the imported treasure map, and then the properties width and height set the dimension of the image. OnClick assigns the function handle click that we will write later, which will be responsible of handling click events on the image. Now we have a paragraph element that contains a heading to display the distance hint state. This gives the user feedback on how close they are to finding the treasure. And then two other paragraph elements that display the total number of games played and the total number of games won. And next we will define several constants and utility functions that are essential for the game's functionality. For example, these include setting the dimension of the game area, generating random numbers for the treasure's location, and calculating the distance between the player's clicks and the treasure. So the first constants are width and height, and they basically define the dimensions of the game area. Both width and height are set to 400 pixels, meaning the game area is 400 by 400 pixel square. And then we create a random number generator, which is a function that generates a random number between 0 and the specified size. Math.random by size generates a random floating point number between 0 inclusive and size exclusive. Then math.floor rounds this number down to the nearest integer. Basically, this function will be used to randomly position the treasure within the game area. Then we have a function called getDistance that calculates the distance between the user's click and the treasure's position. It takes two parameters, e, which is the event click, the click event, and target, which is an object containing the x and y coordinates of the treasure. And to calculate the distance between the user's click and the target location on the map, we will apply the Pythagorean theorem. And the way we will be applying this theorem is by first getting the x-axis difference. This e.native event dot offset x gives the x coordinate of the click relative to the map, and target dot x is the x coordinate of the treasure. And here in this constant we store the difference between the click's x coordinate and the treasure's x coordinate. Next, same process but regarding the I coordinate, and in the return statement is where the distance is calculated using the Pythagorean theorem. Because remember, according to the Pythagorean theorem, the distance between 2 points in a 2D space can be calculated as the square root of the sum of the squares of the difference in their x and y coordinates. And before we continue, let's add something here in the target state that I forgot. And here we have to initialize the target state with random coordinates. So this randomness guarantees that the treasure is hidden at a different location within the map's dimensions each time the game starts. And for that, we created an initial state object with x and y properties, which by applying this random number function, it will generate a random integer between 0 and 4000 pixels, which are defined in this constant that we also have to set to this image tag as width h. This will ensure that the image is displayed at the correct sites within the game. Keep in mind the game's logic relies on the width and height constant, with that were both set to 400 pixels, which means that the random coordinates for the treasures and the distance calculated for hints will be based on these constants. Alright, so this function get distance hint provides the player with a feedback on how close they are to the treasure. This function converts a numeric distance into a user-friendly hint about proximity to the treasure. The argument it takes is about the distance between the player's click and the treasure, and based on this distance, the function returns a string that gives a hint about how close the player is to finding the treasure. For example, if the distance is less than 30 pixels, it returns boiling hot. It means the player is very close to find the treasure. And if the distance is between 30 and 40 pixels, it's really hot, which means it's close but not as close as when it's boiling hot, and so on with the rest of the verifications. I'm sorry, there is a mistake here. It's capital letter is wrong. It's just like this. Sorry. So this use effect hook allows you to run side effects in your function components. It takes two arguments, a function effect and the dependency array. The effect function runs after the component renders, and this empty dependency array means this effect runs only once. And the purpose of this use effect is to initialize the state with the values from the local storage when the component mounts, which ensures that the game history persists between sessions. Keep in mind that without using local storage, as we don't have any database, the game's data will be lost as soon as the page is refreshed. So with local storage, we are kind of preserving the game's data. So local storage is a web API that allows for the storage of key value pairs in the web browser. And here with the method getItem, we retrieve the value associated with a specific key in local storage. If the key exists, it returns the stored value as a string. Games played is the key of this method, and this value represents the total number of games the user has played. Same process here. It retrieves the value stored under the key games won, and this value represents the array of the number of clicks taken to win each game. And then we check if there is a value stored in local storage for games played, and if there is a value, we convert it to an integer, and we have to convert this value from a string to an integer because local storage stores all values as strings, and games played is meant to represent a numerical value. So parseInt function in JavaScript is used to convert a string to an integer. The second argument 10 specifies the base of the numerical system to be used. Same process here. Here we check if there is a stored value for game won in local storage, and if there is, it parses this value and updates the state of the component. And here we have to store complex data types like arrays, and with json.parse we convert the string representation of the array back into a JavaScript array before updating the state. Without parsing this JSON string, the stored data would be treated as string rather than an array. And now let's move on to the handleClick function, which would be the core of the interactive game logic, as it will handle user clicks on the treasure map, calculates the distance, provide feedback, and update the game states accordingly. So when the user clicks on the map, this handleClick function will trigger, incrementing the click counter and so on. So first we handle the user's click event on the treasure map. Here we update the clicks state, incrementing the click count by 1 each time the map is clicked. And then we calculate the distance between the user's click position and the treasure position. And the getDistance function is called to calculate this distance based on the coordinates of the click event and the coordinates of the target, which is the treasure. And then after calculating the distance between the click and the hidden treasure, the game needs to provide a user hint that indicates how close the player is to finding the treasure. And for that, this we call this function that we defined here, which needs a parameter which is the distance, and here is where this function comes into play. When we call that function, it takes the distance value and returns a string that indicates the proximity of the user's click. And based on the distance, the function returns a hint, which is a string that describes how close the player is to the treasure. Freezing is very far, boiling hot is very close. And this is what the feedback is about. After that, we have to handle what happens when the treasure is found. And here is where this if statement comes into action, because it checks if the distance is less than 20 pixels, as we define here. If 30 is boiling hot, then 20 is much more than that. So it is considered that we can consider that the treasure is found. So the 20 pixel margin ensures the game throw an alert or this toast success message saying that the treasure was found. To install this toast package, you just have to install this React Toastify. This guarantees you have this functionality available in your project. So then once you have installed it, this is a function from that library that displays a success toast message. And the message includes the number of clicks it took to find the treasure. And then here we update the total number of games played and store this information in local storage. And for that we use this state setter function that updates the games played variable that we define in this use state. And it takes a function as an argument which receives the previous state value. Then we increment it by 1, save the updated number of games played in local storage under the key games played, and then by this return we update the state with a new value, because updating the state games played makes sure that we reflect the total number of games played, which can then be displayed to the user. And then we have to update the record of games won, which involves adding the current games clicked count to the list of games won and saving this updated list in local storage. And very similar to games played, we apply this state setter function for the variable games won, which again takes a function as argument. And then we create an array that includes all previous games won and add the current games click count to the end of the list. So then we convert the new list of games won to a JSON string, and we save it in local storage under the key games1. In this way we ensure that the data persists even though we refresh our page, and in this way the player can see their past performance even after closing or reopening the game. And why we have to convert the list to a JSON string? Because remember, when working with local storage, the data must be stored as a string. Local storage only supports storing data as key value pairs where both the key and value must be strings, which means you cannot directly store arrays or objects without converting them to a string format. So this method converts a JavaScript object or array into a JSON string. And finally, once the player finds the treasure, the game needs to reset for a new round. And this involves setting a new target location for the treasure, resetting the click count, and clearing the distance hint. So now remember that thanks to local storage we could create a sort of games history, which includes the total number of games played and the details of games won. And here is where we should create an additional function that provides a way for the player to reset the game's history. So this handle reset function provides a way for the player to reset the game's history, including the total number of games played and the details of the games won. Additionally, the HTML elements display this information and provides a button to trigger the reset, as you see here. But the goal of this function is to reset and to clear both the state and local storage of the records of games played and games won. So set games played to 0, we are resetting the state variable games played to 0. Then we reset the state variable games won to an empty array. And then we start clearing the local storage by this method remove item. We are removing the games played item from local storage. And last, we display an informational toast notification to the user indicating that the game history has been reset. And when the reset game history button is clicked, the function handle reset is executed. And this is the tag for the toast notifications. And remember, this is a component from the React Toastify library that renders toast notifications on the screen that we have to import here right at the beginning. And we need to install by npm install React Toastify.